Section 2.4 is about scatter plots and trend lines. As I watch people work on this in class, I think a lot of people are fairly good at drawing the scatter plot, although having a little bit of trouble finding the axis and the scales. And then people are pretty good at drawing a trend line. Writing the equation for the trend line is particularly hard for people. So if you're good at the first parts but have trouble writing the equation, you might skip ahead a little on the video and just do that part. So we're going to do the whole process here, though. This problem says the table below shows the number of Japanese yen in $1 US for the years 2002 through 2006. Let t equal 0 represent 2002. And we have our table, and our directions say draw a scatter plot. They ask whether the data has a positive correlation, a negative correlation, or no correlation. And then we need to draw a trend line and write an equation for the trend line. So this thing about let t equal 0 represent 2002, remember that the reason for that is if you don't do that, you either have to do a break in your scale, or you'd have to have a gap of 2002 points before you started your graph, because your first year value is 2002. So a little technique that we use in the book is to let 0 equal the first year and then calculate out what the other ones are. So 2002 is year 0, then 2003 is year 1, 2004 is year 2, and so on. The other thing to notice is that, remember that in a table, the top line is the x-axis and the bottom line is the y-axis. So when you're making your graph, make sure you're careful about where those go. So then we need an axis label. So remember, if this is the x value, then our axis label is the year. And since we did the years since 2002, that's what we'll label there. And then the y we said was the value, so that's what we're going to use as the vertical axis label. So here are our labels. The vertical axis is the value of $1 in Japanese yen. Just got that from here, the number of Japanese yen in $1 US. And then this is years since 2002. That's the way we defined it. So those axis labels are really important, because otherwise either you get your graph backwards, or if you leave them off, we don't even know what the graph means, and so the graph has no meaning. So then the next thing we want to do is find the scale. We've got this blank graph here, and we've got some numbers to graph. And so I'm not going to go into a lot of detail with this, but basically you're sort of playing around with the numbers a little bit. So I'm looking at what's my smallest x value, 0. What's my largest, 4. So that helps me define the horizontal scale down here. And then my smallest y value, so don't make the mistake of looking at this one and this one. Look all the way across for the largest and smallest. So this is the largest, but then the smallest is actually here. So we know this scale here needs to go from 104 to at least 131 and a little more up here. So I have to play around with some different scales, given the number of squares I have, and see what'll fit those two scales. So here's what I came up with. So my 104 to 136 on the vertical axis, and 1 to 4 on the horizontal axis. Now, one thing to be really careful about is, you notice my horizontal axis starts at 0, so I'm okay there. But this one does not start at 0. I got 104 up here. Remember, our scale has to be consistent. 2 squares is equal to 4 units. But this first set is actually 104 units. And we can't do that because the vertical scale has to be consistent. So we have the little technique that we use that's just showing this break symbol here that just says, well, we're cutting the graph here so that we don't have to have this extremely tall graph to go all the way down to 0. So you need to put that in to show us that you know that that vertical scale should be consistent all the way up. So then our first thing was to draw a scatter plot of the data. So I just took each one of these points. So this is the point 0 and about 131. So that's this one here. And then the next point is 1 and about 120. So that's this one and so on. So I just graphed all 5 points. Next question says, does the data have a positive correlation, a negative correlation, or no correlation? This is not a very good correlation because when I look at it, it's not completely obvious what direction the trend line ought to go in. But you can see sort of a rough trend of something like this in the data. And so that means that our trend line is going to go downward from left to right. And so that means it's a negative correlation. Remember, negative correlation doesn't mean it's a bad correlation. It just means that that the correlation has a negative slope, that the trend line has a negative slope. So now it says to draw a trend line. So remember that drawing a trend line is approximate. So you might look at my blue trend line here and think that you would have drawn it a little bit different. That's okay, but remember that you need it to roughly follow the slope of all the points together and to go somewhat through the middle of the points. So that's what I've tried to do here. So that's my trend line. Now this is where people start running into trouble, is where they're writing an equation for the trend line. So what I've said to some of you in class is, once you're at the point where you're writing the equation for the trend line, forget all the scatter plot points. So just act like they're not there. Because if you use scatter plot points to find your trend line equation, you're probably going to get it wrong. So you want to act like the scatter plot points aren't there anymore, because to find the equation of a line, we just did that earlier in another video. You have to pick points that are on the line, and you notice on my blue trend line, there's one scatter plot point that's close to the line, but there's actually none of them that are on the line itself. This is the most important thing about this, is you have to pick points that are on the line. So what I've done is looked at my line and tried to find 2 easy to identify points. There are other points I could have picked too, but I wanted ones that were as far apart as possible, and I wanted them to go through nice points that are easy to identify. So the one up on top here is 0, 128, and the one down here is 4, 104. So you notice those are not points, that they're not in this table. At this point, we don't care about this table anymore. Those are the scatter plot points. I am not picking points off that table to find the trend line. I'm picking points that are on the trend line. So now I have my 2 points, and all I'm going to do is use the same procedure we used in an earlier video when you have 2 points and you want to find the equation of the line. So first thing I'm going to do is find the slope using my y2 minus y1 over x2 minus x1. And I always label my points. I'm going to call that number 1 and that number 2. y value of point number 2 minus y value of point number 1 over x value of point number 2 minus x value of point number 1. So I end up with negative 24 over 4, which is negative 6. So remember, all that was is my slope. So I take my general form of the slope-intercept form of an equation, and I'm just going to write in my slope. So y equals, I just plug my slope in there. Now this is where you have to solve for b. So we don't know what b is, but we have a couple of points that we can plug in here. I'm going to pick the harder one just to give you some more practice with this. One of the points is actually quite a bit easier than the other, but I'm going to use the harder one here. So I'm going to put this one in, and remember this is an x value and a y value, like any point is. So I'm going to put in my y value equals negative 6 times my x value plus b. And now you know how to solve equations. So we do 104 equals negative 24 plus b. So I'm going to add 24 to both sides. That means 128 is equal to b. So I go back up to my equation up here, bring this down here, and put in the b that I just found. And my equation of my trend line is negative 6, y equals negative 6x plus